Hello, everyone. Thanks for joining. Good to have you here with us. We hope you had a wonderful start of your new year. A new year that brings another round of sharing our learnings and outputs from the EU Arctic Passion Project. While we're still gathering a few people, we would love to hear from you and have opened a small survey which asks you about your career level, the sector you're involved in, and also your relationship to the Arctic. So please share with us your background and your profession. Our today's Arctic Passion online seminar and dialogue is dedicated to the topic which is of increasing concern. Today we're talking about Arctic wildfires. Specifically, we are introducing you to our service of Arctic Passion, which is INFRA, the Integrated Fire Risk Management System. But before we introduce our distinguished speakers and the framework of this webinar, we would love to hear more about you. We would love to ask you to write us in the chat your name, your background, and why you're here with us. So here's mine as an example. And when I say we, I mean Lisa Großfeld and myself. We are both working for the Association of Polar Early Career Scientists, APEX, and are based at the Wegener Institute in Germany, and are working on the Arctic Passion Project. And according to our survey, we have currently actually about half of our, let's say 2/3 are early career professionals in our room. 1/3 is senior professionals, and the largest portion of you at 50% are working in natural sciences. Otherwise, yeah, most of you are not living in the Arctic, but you are working related to the Arctic in most of terms. You are now able to see the results. So, all right, great to have you all on board. A few housekeeping notes before we get started. Would love to see you and warmly invite you to switch on your cameras. At the same time, Arctic Passion has many friends in many time zones, and today's topic is of relevance to many people on other continents. So for those of them who are not present, we are recording this webinar, so please be aware of that. The recording is made available through the Arctic Passion and APEX websites. We are welcoming any questions you may have and invite you to use the chat, or especially in the second half of the webinar, get actively involved by raising your hand and speaking up yourself. Please mute yourself when you're not speaking. And finally, a few words about your hosts of today. This online seminar dialogue is organized by APEX. That's the Association of Polar Early Career Scientists, in short, APEX. So what is it? It's a network of more than 5,500 people who are interested in the polar and alpine regions from all kinds of disciplines and cultural and national backgrounds. And it's a network from early career scientists for early career scientists, and a platform for exchange on various topics. May it be knowledge transfer, alternative career paths, or just celebrating polar and alpine research. And education and training is an integral part of our work. So APEX is involved in various EU projects, of which Arctic Passion is one of them.
Yeah, so this is a webinar of the Arctic Passion Project together with APEX. We are organizing this webinar series as a tool to communicate our project contents, results, and also use this as a platform for proactive dialogue and discussing ideas, getting feedback on our results. But what is Arctic Passion in general? For those of you who don't know the project, we are a project who's working on improving the network of environmental observing systems in the Arctic. And to achieve this, we are working together with scientific networks, Arctic communities, and also decision makers. And more concretely, we work on a coordinational structure of an integrated observing system. We improve systems and we also develop own services to meet the needs of the people in the Arctic and the larger society. In Arctic Passion, we develop services on different topics. One service is on Indigenous knowledge event databases coming from diverse Arctic communities. Then a service on permafrost, generally on the Arctic environment, the integrated fire risk management that we are talking about today. Also, air pollution is a topic we are covering, safety of shipping, and climate change and marine living resources, noise pollution, and lake ice. And we are presenting these services in our webinars. We did quite a few already, so the bold ones are the ones we presented already. If you want to check that out, please visit our website. And today we are focusing on the integrated fire risk management. It's a web mapping service for wildfires to simplify the access to relevant information and products collecting from different sources. And with this, I would like to welcome our speakers, and I'll stop my screen sharing for now, so you can see the speakers as well. So a warm welcome to our speakers today, who are Vito Vitale, the Director of Research, is working at the Institute of Polar Sciences, that is a part of the National Research Council of Italy. Enrica Nestola, a technologist, and Maurizio Sati, a scientist at the Research Institute on Terrestrial Ecosystems, also a part of the National Research Council of Italy, and Guido Bernardi, president at the technology company CAE, Innovation for a Safer World, and he'll explain a little more about it later. So again, a warm welcome to you all, and also to our audience. And we are curious to hear about your work and also about how we can improve the information about wildfires. And after we are hearing presentations, we will open the floor for the audience to ask questions and give feedback, open for a dialogue. So I would hand over to Vito and Enrica, Maurizio, Guido now.
Thanks, Lisa. I'm really apologize for at least you see my face in the slides. Fortunately, you have some technical problem with the video. Some the new version of the software, I have a problem with my computer. Okay, but Enrica, can you share this? Also help. Can you share the slides? Okay, here. So just move to the next one. So I will try to give very briefly three elements in relation to the services. So why a new service on the wildfire? What we can do more than all the services that are global level, for example, the Global Wildfire Information Service, GWIS, developed by Copernicus, European Commission, and GEO and NASA, is making on the national level, for example, the Canadian Wildfire Information System or the US WIFAS system. What we can do more than them. Analyzing the services at disposal, we identified that there are areas in which we can make some addition. Mainly, the most important is to give more evidence to the local scale. This service, or you can see in the slides, are very broad, very general. They cover all the world or very large areas, but in this way, they also lose a little bit of the local scale. And this is important if you like to use several stakeholders. And the second point is to try to make more easy to transfer the signal and information to a large category of users, also including non-professional users, then eventually can be a little bit worried looking this images than you can see in the screen. So the next slide. So this was our approach, try to add something that can be useful. So the general scheme through which the concept through which infra work is try to collect and select all the information at disposal. There are a lot amount of information at disposal. Try to collect, select what is can be useful, eventually also make capability to develop new products and transfer this to a large end user categories, a very broad categories in different way. For example, without any intermediation, and this directly, so the people directly can reach the platform and this is a sort of level 0 implementation of the infra service, or this information can be managed by people that have responsibility or have expertise and eventually be transformed in messages, in tailored messages for the user and different messages for the different categories. And this is made by level 1 and level 2 implementation. The next slide, please. So to follow a level approach make us possible to implement the service in different way for the different user, different categories, and different expertise, and also instruments they have at disposal. So the level 0 is free accessible. We have a free accessible to the WebGIS platform. There is this infra edges where the people can look a lot of information that we are collecting for many services and are presented, we hope, in a more easy and friendly way, and so can be more manageable. From functionality, we can see evaluation of distance, areas, quick zoom, also export map as images. And so if you like to print something and look something for your scope, so for different scope. The level 1, in the level 1, there is an addition then able to realize tailored messages, also following eventually standard template. And this way, and this information can be distributed through a lot of instruments, phone, social media, and other can be added, not to, if necessary, depending on the user needs. So this is reserved to who can have some role and responsibility, of course, because we can evident anybody can send message around. So, but who is, for example, a local community, a local government can try useful to look and use these instruments to disseminate information through a lot of channels. These two levels are require not too much resources. Our implementation in a cloud computing. So simple little groups can also manage with, so a community can easily use these instruments. The level 2 is for organization or body that can have expertise at disposal and also some budget capability, because in the level 2 it's necessary to run a model, a numerical weather prediction model, and this requires some resources. We have a model with a very high resolution, 1.2 kilometer high resolution, and eventually able us to have also products made by infra and can be at disposal. And then the level 1 can be going to develop tailored messages. So the next slide. All this level can be accessed through a web page we are developed in the frame of the Italian Arctic program on the website. Here is the link. And also on this page, we are aiming to introduce all the documentation to inform, all the tutorial, all elements to help the people to use the infrastructure at the best. So this is the general, and maybe later I will show some practical application at least of the level 0. I give the floor to Enrica, that will talk about important development in the frame of infra.
Okay, thank you very much for inviting me today. I'm very happy to be here and to have the chance to present our last work, which is the characterization of well type for the Canadian region using MODIS MCD12Q1 data. Here you can see the name of all the authors, and my name is Enrica Nestola, and Maurizio Sarti is the corresponding author of this work. Okay, let me explain why I'm here today, and because this paper is relevant to the seminar of today. So our study proposed a methodology to generate fuel map, which can be easily updated on an annual basis. And the fuel map generated through our methodology has been integrated as informational layer in INFRA service, which is the topic of today. Let's start with a bit of context. As you know, Pan-Arctic areas have seen a rising frequency of fire in recent decades, and this is why we use Canadian region as study area. In the early 1990s, Canada developed this Canadian fire behavior prediction system, which was developed to offer some outputs, which are rate of spread, total fuel consumption, add fire intensity. And as you can see, this system, here you have 5 inputs and 2 outputs. You can see this red circle highlighting one of these 5 inputs, which is the fuel type. And this input is highlighted because with our methodology, we want to provide an improvement for this kind of input. Starting with an introduction, we should say what fuel types are. Fuel types refer to vegetation categories with similar behavior in fire propagation. Fuel types are a primary factor in the behavior of wildland fire and their prevention. So mapping fuel type is critical for fire risk prevention. And therefore, having high quality fuel type maps that can be readily updated is crucial. Our methodology involves identifying association between MODIS land cover map and classes and the classes from the fire behavior prediction fuel type map. Because as you can see, the classification, the categorization are different. Here you can see a general workflow of our methodology. You can see 2 steps, the pre-processing phase and the processing phase. The pre-processing phase was needed because the 2 maps have different resolution, so reprojection was needed. And thanks to this phase, the 2 maps could be overlapped. Then with the processing phase, we did a pixel by pixel comparison of the 2 maps. And since the number of classes of the 2 maps were different, we merged some of these classes thanks to the confusion matrix classification algorithm. And we use also the confusion matrix classification algorithm for the accuracy assessment of the new fuel type map that we generated. After completing this process, the classes were associated, as you can see in the table. And in the table, you can see the new fuel type classification system and the link between the MODIS land cover map classes and the fire behavior prediction fuel type classes. This is the main outcome of our study. The figures show the newly generated fuel type map for the Canadian region, derived through our methodology. And here I report again the fire behavior prediction system because this input is improved thanks to our methodology. As you can see, the classification accuracy exceeds the 85%. So our approach was initially developed and tested using Canadian fuel map, but here we demonstrate also potential applicability to other regions. And here there is an example for map of Finland. And for concluding, we can say that our methodology enables annual update of the fuel type maps, that this methodology is cost-effective and easy to access because it relies on freely available resources. and that the integration of our methodology into INFRA service highlights its applicability, providing a valuable resource for advancing wildfire monitoring. Also, the fuel type maps combined with weather forecast data will be used also within the fuel behavior prediction system to produce key layers that provide quantitative estimation, such rate of spread, add fire intensity, and total fuel consumption. And this new layer will be subsequently integrated into INFRA services. And this was my last slide. I give you here the reference of the recent published article and yeah, our email address also.
Thanks, Enrica, for your presentation, also to stay in the time. And now we would like to add another aspect that is can be strongly connected with infra, and Guido will illustrate some capability at CAE that could be extremely useful for improving information in the frame of infra, then infra can provide in relation to the early warning issue. Please, Guido.
Thank you very much. Can you hear me?
Yep.
Very good. I am the president at CAE, which is a company you can actually see in this picture. We are a family-owned company based in Italy, employing 115 people, and our mission is supplying highly reliable monitoring and early warning systems to mitigate risk related to natural hazard and exposure. Today, based on my company previous experience and background, I want to show you an additional operational tool which can be integrated to the infra platform to achieve a significant wildfire risk reduction. What we did together with the National Research Council within the Arctic Passion Project includes monitoring, modeling, and forecast of ignition risk and risk that vegetation will catch fire, basically. Infra, as we said and as we will see, provides a WebGIS platform through which to serve both not expert and expert users, making available information and products provided by many existing and not existing services, so newly established services. This presentation shows the possible upgrade for this service, which includes automatic monitoring and surveillance for the early detection of wildfire ignition. So the focus will be basically on early detection of new fires. Of course, this system has been designed for dedicated staff in charge of the fire detection, validation, and eventually activation of extinguishing operations. Further than this, going even deeper into the operational issues of firefighting, let me point out the possibility which is yet to be implemented. It is a potential application to be developed in the future to support the field operations by forecasting the movement of the fire line depending on fuel, orography, and meteorological conditions. But let's see a little bit more what are the key elements of this early detection system, which is actually the observation station, which has to be installed in the target area. Real-time video detection system with a line of sight range of over 15 kilometers, composed of infrared thermal camera and high-definition camera in the visible spectrum. These two elements are the key sensors of the observing station. They are mounted on a pan-tilt system with a horizontal angle of 360 degrees and a vertical angle of 90 degrees. Further than this, the station operates an anti-theft system with video surveillance devices and presence detection sensors. Other key elements of the observing station include meteorological sensors, especially measuring parameters which contribute to verify the local conditions enabling the fires, such as temperature, air humidity, and precipitations, and wind. An additional important part of the observation station is the high-capacity communication system, which enables the transfer of video and information to the processing server unit. So from the observation station to the processing server unit, and makes everything available to the control room, beside making information available to the control room. On the other direction, let me remind that a good communication system is also the key to enable remote maintenance activities, which is crucial to guarantee continuous operation of the system through the time and acceptable maintenance costs during the operation life of the system. So this is an example of observation tower in the Mediterranean area, where the risk connected to wildfires has always been significant, and several best practices have already been developed to reduce this risk. Observation sites can be arranged on new infrastructures to be built, starting from zero actually, or they can be installed over existing infrastructures. In the Mediterranean area, governments already settled observation towers for human observation in the last decades, which in summer can be arranged into shifts to cover the 24 hours observation during the day. So these towers can be equipped with technology. Of course, imagining a different situation in the Arctic region, also towers dedicated to telecommunication or other scopes can be used. This slide is for datasheet lovers, including a lot of technical details of the state-of-the-art observation technologies. But the only thing I want to point to your attention is the rotation speed of the thermic camera, which can perform the full 360 degrees control in less than 2 minutes. This technology, which is the most performing solution for civil applications, and it has been derived by military applications, of course, is able to detect wildfires early when they are still small, in order to facilitate extinguishing activities as much as possible. The minimum target of the detectable outbreak is a function of the distance of the fire from the detection station. 3 by 3 meters fires can be detected in a line of sight of 15 kilometers. This means that a single observation tower placed in a strategic site may be able to control an area up to 700 square kilometers. Moving with our presentation from the field to the control room, let's talk for a while about the software tools available to the operators, of course, completely integrated to the INFRA platform developed within the project Arctic Passion. Each operator desktop front end is equipped with a page allowing to display in real time the images and videos of the target area, maintain a complete overview of the system functioning, display the recently identified alarms with relevant images and videos. We just said the system displays recently identified alarms. Well, with respect to automatic alarms, the software operates the system according to preset conditions. So, normal state, the system scans the preset target points and record videos of 3 cameras: pre-alarm, closed alarms, confirmed alarms. Of course, it is also possible to track manually alarms in case the user autonomously detects a suspect condition. This happens, for instance, when an individual sees the fire by himself and communicates this event to the authorities by radio or phone. Here Here, I simply want to show you an additional, an example of existing monitoring and early detection system in the Mediterranean area, especially in Apulia region, South Italy. Here we see a system which was implemented by local authorities, composed of 6 automatic fire detection stations in different sites, 6 automatic meteorological stations nearby the fire detection station, and dedicated microwave radio communication link. This project was contracted approximately 6 years ago, and the successful implementation of this first project led the authorities of the same region to implement a second contract to install another similar system 3 years later, so 3 years ago. As a conclusion, of course, conditions in the Arctic region are different from the scenario of the Mediterranean area. First of all, distances are larger, and then much lower anthropic presence has to be taken into account. These observation towers are expensive, and their usage shall be considered only in most strategic spots where a fire can easily evolve into a real risk for population. Among these potential sensitive spots, let me imagine towns and villages, transportation infrastructure, industrial sites, power plants, and key distribution infrastructure of energy, and national parks. Thank you very much. Hope just in case there are questions, I'm here to answer also at the end of the presentation.
Awesome. Thank you so far very much. It was very interesting. While Vito is preparing to give a little demonstration of the INFRA system, I would like to ask our audience to get ready to prepare some questions. I'm sure you have some maybe of technical interest or also science interest. Please post them in the chat and just share them with us, and we are ready to
substitute my. Okay, then I just move to wrap the website. You can, it's necessary through the web page. Okay, here, this web page offers you the possibility to access, for example, and this is a level 0 for a test area of Canada, and it's okay. Okay, so for example, I would like to show an example how this service can be useful. If I set the 10th of August, okay, it's coming very slowly. You can see a lot of fires. I have no idea why here should be a rectangle around Inuvik. Here is, we are in the Inuvik area, and the one of the most important elements should be, okay, now it's arrived. I'm sorry, my web connection today, I don't know why. Okay. You can see now, this rectangle is an area of 50 kilometers around Inuvik. Inuvik here, 10th of August, the fire arrived very near to the city, the town, 10 kilometers, and an alert for a possible evacuation was launched. No, and was persistent for 7 days. It was removed just 18th of August. For 7 days, the people was under the risk. But the information provided by Inuvik, by it moves very slowly. Okay. Here you can see the function of a slideshow. You can check, for example, the risk analysis for a period. Here you can set the period. Then, for example, I can move from 07:20 till 08:20. I can, the forecast, you can have 8 days in advance of information about the risk. And if you follow, and now the web is very low, so I will follow manually day by day, and you can see now I can enlarge a little bit the perimeter just to show. I'm sorry for the slow internet connection. So you can see then if I move along the time, the risk was moderate, no? And now it's move very slowly. So you need to wait a time to move from one day to another and see the layer. But if you follow, if you go on the website and we look, you will see then after the 10th of August, the risk will reduce dramatically, no? So following the, using INFRA, you can be a little bit more confident on the positive behavior of the, because of course you are in the hurry. You are receiving an alert, the situation is very critical. What can happen? Of course, you are waiting for information, but eventually INFRA can help you to detect information, always provided by the same source, but have a more friendly in your hands to see what happened and try to understand a little bit more. And more this will be used, more and more the exercise will be done, you will become more expert and you will understand more. In this case, now it's very difficult due to the internet speed at the moment, but if you move and follow using the slideshow what happened from 10th of August ahead, and any I can have a forecast for the risk of the vegetation can propagate fire or eventually ignition risk. I can see then the risk is much lower. It was much lower the week from 10 until 20. And so, for example, to look to the information with a less stress and try to understand. And anytime I like to understand what happened, I can go on the platform and try to follow. Of course, this means also to develop training tutorial and make the people more experienced. But it's no different of the approach than the weather forecast is doing. We are preparing material, etc. Now here I try to ask you to reach and check, because at the moment, really, this is very difficult due to you can see, yeah, the change of the, okay, and probably I was not able to make any change in the input until 20th of August. I can move more, okay, and I can see then. Yeah, you can see how in the day after 10, you can see the fire risk is changing. Okay, and we can move. You can see then, you can see now in slow time it will appear. Now is you can see the risk is much lower. The green is very low risk, and so you can be confident in the capability of the emergency system to manage the fire and the possibility the fire will stop and not reach the city. So it's a way to approach other issue, other question. We will try to make more demonstration. I'm sorry that some technical problem make it very difficult to show you in the best way at the moment. But this is just to tell you a potentiality. Okay, I believe that now for now is anything is better to stop now and ask to the people for some question and try to answer into question to make more information on the potentiality.
Thank you, Vito. Thank you so much for sharing and giving us this insight. I think people will have a chance to browse to the website themselves and test it. Yeah, we would like to open the floor for questions. There are quite many people in the room with experience, either science-wise or even personally living in areas where wildfires are a real threat. So we would love to hear your opinion, also hear your voices. If you have questions, please let us know. And as Lisa wrote, please, you can post on the chat or just raise your hand. That would be much appreciated to get your input and insights. Yeah, Lisa, you want to start?
Yeah.
I see you're moving.
I was just wondering if you can repeat, as you were telling, that you can follow the development and the extent of the fire. How quickly is the information available on the platform?
The data, okay, the data coming from GV, so other normally are updated daily. So, and so any day you can have for the risk, you can have the information forecast in GV's system. The forecast is for the next 8 days. So you can have an information for an average level for the day. Normally it's indicated for a time, but so it's one information per day, and this every day is adjourned another day. So you can have a daily an improvement of this information at the level 2, and our meteo information are with a periodicity of 3 hours. Every 3 hours you can have 12 meteo field, including some information layer about the possible risk for lightnings. So
Okay.
typically 1 per day, and every day you can have a new information and new days, because you can go ahead up to 8 days more the day the data where you are.
Thank you.
So
Yeah,
this is the
thank you so
typical
much.
approach.
We have a question from Mark.
Yeah. Hi.
Sorry?
Thanks, Vito. Thanks to the other presenters. This looks really great. So I'm Mark Parrington. I'm from the European Centre for Medium Range Weather Forecasts and work as part of the Copernicus Atmosphere Monitoring Service. And we do sort of routine monitoring of global wildfire emissions and smoke transport, air quality, potential air quality impacts on a sort of regular basis. And during the summer, I've spent a lot of time looking at the Arctic. So I think this kind of system with that additional local information is going to be invaluable, particularly I think it's getting more focus. So I just have 2 very quick questions. So the first, you showed you have MODIS and VIIRS data that's included in the platform. I was wondering if you plan to then extend that to other sensors. And the second question is maybe more like along the lines of the work I'm doing is, you mentioned in is it the level 2 support, the high resolution numerical weather forecasting. And I just wondered if there's any plans to include some kind of smoke dispersion or something in that kind of platform at some point.
Yes. Okay. The first question is so the first question is about and in fact we try to consider the fuel map at the moment. I don't know, but Enrica and Maurizio can answer better than me. If we have no plan, the real scope was trying to not to invent other effort and to make a lot of products, because a lot of information coming from you. And for Copernicus, GVs, the national services are at disposal. And before to move to new, can be very nice to use at the best and put at disposal at the best what is at disposal, because the use of these products is not very large, mainly in the general audience, not in the expert community, but in the public. So at the end, how much the people can use the huge amount of effort made. About the second one is that the high resolution. The question is if we are implementing this.
You mentioned the NWP forecast, the high resolution. And I just wondered, as part of that, would there be some plan to add like a smoke
the model
tracer
is at
or
disposal. We are this needs the resources to be routinely running. Is running in Italy. This is an high resolution model developed at the CNR in Bologna, and routinely you can find this Moloch Bolam. I didn't see the name before, but these are routinely running in Italy. So we are our intention to make as a demonstration an operational service using this model and implementing infra for Italy. This will be a demonstration, of course, to be applied in the Arctic in some area. We need to have a stakeholder and like to have and put the resources, because we have developed the level 2 at the moment at the demo level. So we have a 2 annual season, fire annual season, 2021 and 2022, where we run the model, we develop all the products, and we are able to show what happened. It's the level 2 is, if you like, we can provide you the username and password for this test and to run and provide feedback. This will be on one. And we would like to realize an operational implementation of infra, a level 2 for Italy, since we have the model running yet, so will be no very costly to implement an operation. It can become also a way to present infra and eventually see if other will be interested to implement a level 2 of infra for some specific area in the Arctic. Level 0 can be extended everywhere, because we are not using modeling and just taking products for others. So until these products are at disposal. Now, your other is about the smoke. Yeah, we are interested to connect with the Aurora service, and we are yet in discussion to have some additional layers provided by Copernicus. So Copernicus is providing some routine modeling products for the aerosol produced by wildfires, and we are discussing with our colleagues in Jane Research Center to receive this information and add this layer in infra.
Okay,
Yes.
great, thanks. Yeah, if it's CAMS data and you have any sort of need any support for that, then yeah, feel free to reach out and we'll be happy to support.
For the European area, we can provide PM10 at the end, because this is provided by Aurora, and a couple of products of Copernicus. But for the global scale, there is only one product by Copernicus. I believe is the overall mass emitted by wildfires.
Yeah.
And this is a global product, and so we'll be able to introduce this products in the frame. So in the case of Inuit, eventually to give also information relation to the smoke. Yes, but this is something on which to work, trying to use water disposal, because this is an addition that never was developed up to now. So even GV, so other services normally provide information on wildfires, but no information on the smoke. So you need to reach two places to have all information, and we will try to combine and have all in one place to make more easy for the people.
Okay, great, thank you.
Yes.
Thank you. Thanks for the question and the discussion. I would like to raise a question from Emily in the chat, who asked what was infra used for so far? Has it been used by larger organizations or governments? What's your knowledge about this?
No, we are trying to. Okay, we are trying to engage the stakeholder. The platform was just developed, and we need to improve the connection with the stakeholder and try to understand in which way they can be interested to use this platform. We are making several attempts to connect, and also we are organizing now, for example, a webinar in May. We are discussing with Aurora to have a webinar specifically devoted to receive feedback on what we are doing. So the idea is that infra can be useful to increase awareness of the people. And mainly, we are not trying to make new products, but try to provide instruments to make more easy communicate and transfer information to the people. So this is the main scope of infra. Of course, this scope needs a strong interaction with the stakeholder, and we are trying strongly to make this connection and make this connection real and fruitful. At the moment, not too much success, I need to say. And also we have trying to connect with the local municipalities or local governments, and it seems to be a long journey and not easy to achieve. Probably we need to ask if you have using the best channel. Any suggestion from this point of view are highly welcome.
We have a raised hand by Curtis, and I think you're also having experiences with wildfires, so we really appreciate you being here and also getting up so early. So the floor is yours.
I cheated. I set my alarm.
Ah, perfect.
No,
Vito, thanks
yeah.
for the work that you did for us on the glaciers and stuff like that for the glacier retreat. So Curtis, I'm from Northwestern British Columbia. And so one of the projects you helped us out with is the imaging on glacial loss in our traditional territory. I'm just wondering if there's other training or tutorials on how to use that website. And I see that there's areas of interest in there, and I've been playing around with the website and stuff like that. And it looks like there's data shows up for areas outside these areas of interest. Is that correct?
Yeah, in effect, level 0, since we are taking information from the other services, until the services are providing us data, we can extend the area. No problem.
Okay.
The area, the testing area, was selected mainly for the modeling run that need to be limited
Okay.
for resources budget, and so at the end is also remain for the level 0, but the level 0 in practice we can implement any area. If you provide us an area for your specific scope, we can set an implementation. We can develop, we can implement how many versions of INFRA, because it's a cloud computing. So we simply need to change some parameter, and then we can set a specific implementation for a specific case, a specific user. Also, we can, so the problem is only your need in specific. So what done up to now is an attempt to show potentiality. But we hope now strongly discuss with the people and try to make some concrete implementation for a concrete use, even this summer, for example. So
And is
ready
there
to discuss, also to visit and try to discuss together how to make an implementation that you like to use and you can use for your specific scope.
Okay, so I just contact you directly to set something like that up?
Absolutely. Yeah.
Okay, and then the
Yeah.
other question, is there online training or tutorials on how to use the website?
We are in the web page that I showed before. We present anything. We are preparing a more large video tutorial. There will be 7-8 minutes. The anything is set at the scenery, the script and the text is ready. We are just waiting to fix some little items on the platform. In this way, the video can show the last evolution of the platform. And I hope for Easter to have this tutorial at disposal. And anything will be presented in this unique web page. So the idea is to have only one point where anything can be found. The possible material there is presented, many at the moment, but we hope soon to have filled them with something.
Okay, thanks.
It is only at the problem of the time, a lot of duties, but the plan is very clear. But
Thank you so
please
much,
contact
Vito.
and we can have interaction and make rapidly a useful application for you.
Thank you. I think it also gives a good outlook of what we can still expect, and it's great to see this development. Vito, you may want to answer Emily's question in the chat. I have one question, the last one from my side. Maybe you can take one more from the audience, but we'll close this webinar also soon. So pose the question now. I have one question to Guido. Development or technical development you have done with this tower, I was asking all my staff how this early detection could work for tundra and very flat terrain. Is this different than from what we have in like the Mediterranean? How can this technical developments be applied in the Arctic?
Talking about the early
Yes,
warning? Or?
yes, yes. Actually the technology is based on infrared thermic cameras. So the idea is until there is a line of sight on the fire, direct sight of the fire, the system will certainly work because it actually distinguishes the fire from non-burning areas. And actually the good news compared to the past is that now these algorithms really work and they can really detect fires and distinguish fires from other things. It was not the same some years ago. So basically, a lot of institutions and agencies had bad experiences in the last maybe 10 or 20 years, but now the technology is different and it is effective.
So great. So
another important element, I believe, is then technology. This sort of technology will improve more and more. So any improvement in technology will introduce more capability in this system. So the system is can have a dynamic evolution. Then they will work better and better. Meanwhile, the algorithms and also the hardware is improving. So any improvement will be beneficial for the system. So implement the system can be an investment because at the end, this will be better and better and better. No doubt on the line progress.
Awesome. Well, thank you so much. I think after distinguishing the fires, extinguishing is the next step. So let's see how future will develop here. Thanks for sharing the article, Enrique, and the chat. And I guess with this, we are coming to the end of this online seminar and dialogue. Vito, Guido, Enrique, thank you so much for sharing today, and all your contributing colleagues for your hard work in this direction. It was a pleasure to see the developments in Arctic Passion and in Infra. And also, dear audience, thanks for your time and great questions today. Hopefully see you soon again in one of our next Arctic Passion online seminars. Once again, thank you all for joining, and have a great rest of your day or start of your day.